Okay, what this little bird's saying is, I'm stuck in this flight pattern right now because this is going to be a long video. So hunker in, get ready to go. It's not recording. It is. Okay. Sorry. Should have edited that. I'm moving on. Okay, we're going to graph a quadratic. Remember, a quadratic is y equals ax squared plus bx plus c. You have factored them, you have solved them, you have had all sorts of fun with them. Now we're going to graph them. When you graph them, you get this thing that looks like this red U, and it is called a parabola. Okay, we're going to identify the different parts. There are lots of parts of a parabola because if you build it, they will come. We're going to build the parabola, and we're going to talk about how we get them, but for right now, we're just going to look at a parabola and find those parts. So the first thing is called the axis of symmetry, and you don't see it. It's invisible. So it is invisible. You can't see it, but we can put it in there. It is a vertical line that goes right through the middle. If you folded that, the left side and the right side would equal each other. That's what symmetry is. It says it's basically the same on the left and the right. If you take a line going through your eyes, down your nose, and through the middle of your body, your left side pretty much is identical to your right side. So if you folded yourself in half, you would be symmetrical. Because it is a vertical line, remember our old friend Vux, that means the equation is x equals. What do all those x's equal? They all equal 1. So this is the equation, x equals 1. We need to know that, but it's not technically part of our equation, of our graph, okay? The vertex is the bottom point or the top point. It's where the curve turns. It's a point. So from the origin, we went right 1 and down 4. So it is at the point right 1, down 4. This parabola, your choice is either up or down. This parabola opens like that, which is up. The arrows point up. It's going up, 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 up. Okay? The y-intercept is the same thing it's always been. It's the point where the graph crosses the y-axis. So it's at the point 0, because remember we can't go left or right, we just want to go down 3. So it's the point on the y-axis. That's the same thing that it's been all along. Remember y equals mx plus b, we graphed that point on the y-axis first. The symmetric point, I'm going to keep it the same color. It's the one directly across from the y-intercept. So what you do is you go to the y-intercept, you walk to the axis of symmetry, and you walk over. How many steps did you take? You took 2 steps, and you're down 3. So it's at the point right 2, down 3. The solutions, you just did an entire unit on solutions. This is where you let y equal 0. So this is where they cross the x-axis. They're the x-intercepts, remember? There's one here and one there. And for solutions, you're going to give me what x equals. That's what you did last unit when you solved using the quadratic formula. So on this one on the left, x is equal to -1. On the one on the right, x is equal to 3. The maximum and the minimum are either or. You either have a maximum or you have a minimum. Maximum is the top point. Minimum is the bottom point. So in this case, it's where it turns. It's where the curve turns. The curve turns right here. That's where your curve turns. So you have a minimum because it's on the bottom. And all you want to know is how low does it go? How low does this parabola go? If you look, it goes up forever and ever and ever, ever and ever and ever. But it stops at one point of how low? And 1, 2, 3, 4. That's down 4. So the minimum is down 4. Every other point is going to be above that point, okay? The next two, increasing or decreasing, this is going to be from left to right. So both of these are, you look from left to right. So I'm going to start at the very left. The very left is this arrow. And I'm going to go along the parabola to the vertex. What did I do? It went down. So it is decreasing. That means it's going down, okay? Where is it decreasing? It's decreasing everywhere from the vertex left. So remember, the vertex has a value of x equals 1. So every point where x is less than 1, it's going down. Where is it increasing? That means where is it going up? From the vertex, it goes up everywhere to the right of the vertex. So it's going to be x is greater than 1. Okay, let's look at another one. So what is the graph of a quadratic called? It's called a parabola. So we want to identify the parts of the parabola. So the first thing is the axis of symmetry. Remember, that's the invisible line that goes through the vertex. What are all the x's right here? They're over 3. So your axis of symmetry is x equals 3. The vertex is the point where it turns. It's a point, so you went right 3, up 1. Look at the arrows. The arrows are going down, so this opens down. Y-intercept is the point where it crosses the y-axis, which is right here. It's always at 0, and then it's, in this case, down 1, 2, 3, 4, 5, 6, 7, 8, down 8. The symmetric point is directly across from the y-intercept. So we walk to the axis of symmetry, 1, 2, 3 steps. So we got to take the same amount because remember it mirrors it. It's a mirror image. 1, 2, 3 more. So altogether we walked 6 steps and we're still down 8. Okay? The solutions are the 2 points. Oh, that color doesn't work. Are the 2 points on the y-axis. They're the x values when y is equal to 0. So in this case, this is an x of 2 on the left. The one on the right is where x is 4. So we have a point at the top, right? Our vertex is at the top, which means it's a maximum. Remember, maximums are at the top, minimums are at the bottom. How high does it go? It goes down forever, but what's the highest point ever? That maximum is 1. It will only go up 1. It won't go any higher than that. We're going to go from left to right. So in this case, from left to right, I grab that arrow, I go to the vertex, and I am going up, which means it is increasing on the left of the vertex. It's increasing on the left. So that's everything smaller than the axis of symmetry value. Everything smaller than 3 is going to be increasing. Looks like it's decreasing because it's going down. But remember, we read from left to right, so we copy from left to right. Then the last thing is from left to right, from the vertex over, it is going down. So that means everything to the right of the axis of symmetry is decreasing. Okay. So checkpoint 1, you're going to find all those parts. Remember, the only thing I'm going to give you a hint on, the axis of symmetry is that invisible line that's not part of your graph that goes through the vertex. So pause this and try this before you come to class. What are we going to do if they give us an equation and they don't give us a graph and we have to find all these parts? Well, the first thing you're going to do is the same thing that you do pretty much every time you deal with a quadratic. You're going to identify A, B, negative B, and C. To find the axis of symmetry, there is a formula you have to learn. It's x equals negative B over 2A. Now, you had an old friend formula here, and you had this guy. Remember this? X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. That's the quadratic formula. Look, it's pretty much the quadratic formula without the discriminant. Whoa, mind blown. To find the vertex, you're going to plug in that axis of symmetry value, because you're going to get like x equals 5, x equals 7. You're going to plug that number into the equation, and you're going to get a point. When you do that, you're going to say y equals a times whatever that value is squared, plus b times whatever that value is plus c. These are all numbers, so that's going to give you y. So you'll get a point, x, which was that axis of symmetry value, y, what you get when you plug it in. The y-intercept is always where x is 0. So if you do that, you get y equals a times 0 squared plus b times 0 plus c. That's 0 plus 0 plus c, which is just c. The symmetric point, remember, you walk from the y-intercept to the axis of symmetry, and then you walk that much space again. So it's 2 times the axis of symmetry, comma, c, because it's up at the same height. The solutions are where you either factor to find the solutions or you use the quadratic formula. You just spent an entire unit solving quadratics, so you know how to do that. Look, I did the quadratic formula in that color. Okay, the next part is which way does it open? All right, it will open up. Remember where the arrows go up, up, up if A is positive. It will open down, which means the end arrows go down, down, down if A is negative. So that totally depends on A. The maximum or the minimum, it occurs at the vertex. It's where the curve is, up here or down here. This is a max. This is a min. Remember, max is at the top. Minimum is at the bottom. The y value of the, nope, that's the wrong thing. Sorry. I can't erase either. My eraser doesn't. Oh, it worked. It worked. It worked. Yay. Okay. Won't work everything. Okay. So the max or the min, depending on which it is the y value of the vertex. Sorry about that. Okay. Where does it increase? It increases where the graph goes up from left to right, and it decreases where the graph goes down from left to right. So here, from left to right, we are increasing here. Here, from left to right, we are decreasing. So it's whichever way it's going from left to right, okay? So to identify where it's increasing or decreasing, you write an inequality. So anything, whatever it's doing to the left of the vertex, your inequality is going to be x is less than your AOS value. To the right of the vertex, your inequality is going to be x is greater than the AOS value. Because here, whatever the AOS is, this is less than, both of those are less than. If I go to the right, both of those are greater than. Whew, so confusing. What do you do when you're done with that? You plot all the points, you draw a curve, boom, you are done. All right, here we go. Let's do one. What is the graph of a quadratic equation called? A parabola. You got to know that. Get it in the form ax squared plus bx plus c. We got it. Check. So all we're going to do on this slide is identify a, b, and c. A is 1. B is 6. The opposite of b is -6. And c is 8. Remember, just like in the quadratic formula. Got it. So what is it called? It's called a parabola. I think I stopped that after this slide. Get it into the form. This is what we're looking at. So this is what we already know. We found A, B, and C. We got to find the axis of symmetry. So the axis of symmetry is -b over 2a. That's -6 over 2 times 1. That's -6 over 2, which is -3. So your axis of symmetry is x equals -3. It's always going to have that x equals. Look, his little wings kind of look like an X. Whoa, he's a little axis of symmetry. All right, So we're still doing the same thing. This is what we know. We found A, B, and C. We found the axis of symmetry. We got to find the vertex. So to find the vertex, it says plug the axis of symmetry value into the equation to get the y value. So the vertex, you know x. Look at right here. It says x is -3. To find y, it tells you what to do up here. It says take x and square it, add 6 times x, and then add 8. You can do this on your calculator, or you can do it by hand. -3 squared is 9. 6 times -3 is -18, plus 8. -9 plus 8 is -1. What's -1? Y. So there's your vertex, -3, -1. All right, so we got to get it in the form. We're still doing the same thing. Here's what we know already. So which way does it open? It opens up or it opens down? Look at it. He's opening up, or is he opening down? He's got parabolas everywhere, doesn't he? If A is positive, oops, opens up and down. It's supposed to be what color? Oh, it's purple, good. Positive, it opens up. If A is negative, it opens down. So this parabola opens. This is what we need. It opens up because A is positive. All right, we're going to graph it. So our axis of symmetry, I'm going to write all this in. Our axis of symmetry was x equals, I'm on the wrong graph, x equals -3. So if I go to -3, that's my axis of symmetry, right? My vertex, we found, was the point -3, -1. So I go left 3, down 1. There's my vertex. I know it opens up. If I don't get up, that means I messed up, right? My y-intercept was the point 0, 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8, right there. To get my symmetric point, I went to the y-intercept and I walked that many over. I took 2 times the axis of symmetry, so -6, 8. So it's right there. The solutions are on the x-axis, and we found out our solutions. Did we find our solutions? We did not. Well, let's do that now. Oh my gosh, we don't know it. We only know the max min. So the solutions say either use the quadratic formula or factor it. So I'm going to go white here so I can see it well. So I've got x squared plus 6x plus 8. I'm going to try to factor. Are there factors of 8 that add up to 6? Yes, 4 and 2. So x squared plus 4x plus 2x plus 8. Pull out the x, x plus 4. Pull out the 2, x plus 4. I get x plus 4 times x plus 2. When I'm solving it, remember I set it equal to 0. So x plus 4 is 0, so one solution is x equals -4. X plus 2 is 0, so one solution is x equals -2. So there's -2, there's -4. So we said plot the points and sketch the graph. So let's do that. Whoops, I let go. There's my parabola. Oh, it opens up. Yay! So the question is there a max or a min? And we're going to look at the graph. It's got a bottom point, which means it is a minimum. And how low does this go? It goes to the y of the vertex, which is -1. Okay, I shouldn't have done that on that slide. So let's look at that again. So here we go, down here, this is a bottom point. A bottom point means we have a minimum. How low does it go? -1. So now let's find where it's increasing or decreasing. So the function increases from left to right when it goes up, and it decreases when it goes down. So I'm going to grab from left down to right. Remember, let's draw in there. That was x equals -3. And so it increases, nope, it's decreasing here, isn't it? It's going down. So it decreases to the left of the axis of symmetry. From the right of the axis of symmetry, it's going up, so it increases to the right of the axis of symmetry. Craziness. Okay, so now we've got a new one. We're going to sketch the graph. So the first thing we have to do, I'm going to write in white because it's really easier to see. The first thing we have to do is identify A, B, negative B, and C. So A is -1, B is 4, negative B is -4, C is 5. For the, oops, it's down here. Look at that, goober. So that was -1, 4, -4, and 5. For the axis of symmetry, remember right here it tells you the axis of symmetry is negative B over 2A. So that's -4 over 2 times -1. That's -4 over -2, which is 2. So my axis of symmetry is x equals 2. Draw that vertical line. My vertex, remember, I plug that axis of symmetry value in for x. So I have y equals the opposite of 2 squared plus 4 times 2 plus 5. So that's the opposite of 4 plus 8 plus 5. That's 4 plus 5, which is 9. So it's the axis of symmetry point, the vertex. So write 2 up 9 right there. Which way is this going to open? This is going to open down. Okay, my y-intercept is the point 0, what's it say here? 0, C. So C is 5. The symmetric point, it says take 2 for the symmetric point. Let me write it in here. It says 2 times the axis of symmetry, C. So that's 2, the axis of symmetry is 2, C, which is 5. So it's the point 4, 5. So 0, 1, 2, 3, 4, 5, 4, 5. Look, I walked over 2, walked over 2. The solutions, we have to find them. So I've got 0 equals -x squared plus 4x plus 5. Let's do the quadratic formula. X equals -b plus or minus the square root all over 2a. So let me find b squared minus 4ac. So that's 4 squared minus 4 times -1 times 5. That's 16 plus 20, which is 36. So x is going to equal -4 plus or minus 6 all over -2. So -4 plus 6 over -2 is 2 over 2. So one of my solutions is x equals 1. Oops, this is over -2. So my solution is -1. Okay, whoops, mistake. My other solution is -4 minus 6 over -2, -10 over -2, so x equals 5. 1, 2, 3, 4, 5. I can now draw the parabola. That's a pretty good parabola. Look how impressed he is. Ooh, he likes it. So is there a maximum or a minimum? This is up at the top, which means there is a maximum. How high does it go? Remember, it's the y of the vertex, so it's a maximum of 9. From left to right, I start at the bottom, I go up to the oh my gosh, my mind, up to the vertex, so it's increasing on the left, so it's increasing where x is less than 2. From the vertex to the right, I'm going down, so it's decreasing where x is greater than 2. There's a lot of stuff on that slide. I hope you were neater. Okay, special cases are where some of the parts are the same, and that kind of freaks people out. For this part, we're just going to identify them. Next one, we're going to actually graph them, but for today, we're just going to identify them. Axis of symmetry, remember, is that invisible line that is the x value of the vertex, where all the x's are -3. The vertex is where the curve occurs, so it's at -3, 0. This opens down. The y-intercept is where it crosses the y-axis right here. It's at 0, -3. The symmetric point, you walk -3, you walk 3, you walk 3, so you've walked -6 and you're down at -3. The solutions are on the x-axis. Oh, look, it's the same as the vertex. X equals -3. That's all we've got. Is there a maximum or a minimum? Well, this is a top point, so it is a maximum. How high does it go? 0. From left to right, start at the left, go to the vertex. It's going up. It's going up. So it is increasing to the left of the vertex, which is where x is less than -3. From the vertex down to the right, it's going down. So it's decreasing to the right of the vertex, where x is greater than -3. All right. Now we have some special cases where one of the parts is missing. I feel like there should have been a checkpoint there. Nope, goes right to special cases. Okay, let me waste your time by saying that. Where one of the parts is missing or the same as the other part. So let's find our axis of symmetry. X equals 0. Our vertex right down here, 1, 2, 3, 4, 0, -4. This opens up. The y-intercept, I'm trying to keep using the same colors and I keep losing my key. The y-intercept right here is 0, -4. Is there a symmetric point? It's 2 times the axis of symmetry, so it's also 0, -4. So if you look, all of these are the same, so that makes this a special case. But do I have solutions? Are there points on the x-axis? There are, where x is -2 and x is 2. So that's okay that those are the same because I got enough points. As long as I have 3 points, I can graph it. Is there a max or a min? Well, this is at the bottom, so that makes it the minimum. How low does it go? -4. From left to right, start at the left, go to the vertex. I went down, so it's decreasing on the left. So it decreases on the left, which is less than. From the vertex to the other arrow, I went up, so it's increasing to the right. Okay, so there should have been another special case. So our checkpoint here, you got to find all these parts. So some of them might be the same. No big deal. All right, you got this. Good luck. Fly, little birdie, fly, fly. Take your knowledge and fly.